Okay, lesson 11.4 is simplifying rational expressions. And all that rational means is that the number can be written as a fraction, or you have a fraction. So you have 1/2 or 2, they can both be written as fractions. The only thing that is not a fraction is if you have a 0 in the denominator. Anytime you have a number with 0 in the denominator, let's say like 1/0, that is called undefined, because there is no such number with a 0 in the denominator. So that's all the word that that's the only thing that the word rational means. So basically what we're going to be doing today is just simplifying fractions, okay? Now you're used to simplifying fractions, something that looks like this. If I were to give you 6/18, if you were to box that in and tell me that was your answer, I would mark you wrong. Because you should see that and see, okay, I need to simplify that fraction. That fraction can be simplified to 1/3. That is exactly what we are doing today. The only thing different is we've got variables in here, okay? Which makes it a little more in-depth because we've got to follow some more rules. And this is the first major rule. If you can get this, you can simplify any rational expression there is, because this is the #1 cause of mistakes whenever people do this. Any time there is a variable, like let's say right here, this x, and it has a plus or it has a minus, so if it was x minus and a number beside it, so 4, 5, or if it has another variable. So anytime there's a variable with a plus or minus sign beside it, whatever it has is a pair. So like in this problem right here, I've got x plus 5. X plus 5 is a pair. It has parentheses around it. I cannot simplify anything in x plus 5 except another x plus 5. Okay? X plus 5 is together. I cannot break it up. It is a pair. Unless it is over x plus 5, that is the only time it will cancel out. Okay? I cannot say, oh, x plus 5, I'm just writing it right here, x plus 5 is over x, so those cancel out. No, I cannot do that because this x is attached to this 5 and I cannot take them apart. Okay? That is the main thing that you've got to understand. So anytime, in this case, both this first and second problem here already have parentheses around it. But anytime, this is what I want you to get in the habit of saying, anytime you see an x plus or x minus, or let's say it's a y or a z or whatever the variable is, find it and go ahead and put parentheses around it. If you do that, then you're more likely to remember this is a pair and I cannot simplify it without something identical to that. Identical. It can't be, oh, x plus 2. Oh, that could simplify with x plus 4. I'll just leave a 2 somewhere. No. It has to be identical. So get in the habit. Anytime you see a variable with a plus or minus sign beside it, go ahead and put what it's with in parentheses. So you know, this is a pair. I cannot break it apart unless there is something identical to cancel it out with. Okay? Now that I know that, anything else, like this x right here, that's being multiplied or divided is always fair game to cancel out. It's by itself. It does not have a pair. There's no plus or minus sign beside it. So basically, I look in this very first problem. Are there any other x plus 5s to cancel the x plus 5 that I have with? Nope, there's not. So this is basically off limits. I am not going to touch that x plus 5. So right now, I'm basically looking at the problem of 2x over x. And I'm just trying to simplify that, 2x over x. What do you see that is a common term that I could cancel out? The x's. Very good. This has an x and this has an x. Now, is there anything I can cancel the 2 out with? No, there's no other numbers left. So I'm left with 2 over x plus 5. And again, make sure that's in parentheses so you know it's a unit. Okay, it is a pair. Is there anything left for me to simplify in this problem? Nope. This is my final answer. All right, let's look at this next problem. X squared plus 6. They've already got it in parentheses, and I look at my problem. Is there any other x squared plus 6 that I could cancel it out with? No, there's not. So basically, I'm looking at this problem like that does not exist right now because that's not an option for me to cancel out, okay? So right now I'm looking at x over x squared because this is all that I have left. So I can cancel out. Let's look. What does that x squared down here on the bottom mean? How many x's does that mean that I have? 2. So I could rewrite that as x times x if I wanted to. That's just the long way of writing x squared, x times x. So if I have 1x on the top and 2 on the bottom, how many can I cancel out? 1. So I cancel this one out here and this one out. How many am I left with on the bottom? 1. I'm still left with 1 on the bottom. So don't sit there and cancel, oh, x and x squared, they cancel out. No, because this one down here has 2 x's, so I'm still going to be left with 1. So I can rewrite this, since that x goes away, as x squared plus 6 over x. That is my final answer. Now listen carefully here. Fight this urge, because this is what people want to do, is they see this right here and they go, oh, cancel, cancel, I'm left with x, so I've got x plus 6 is my final answer. No, because that x squared has a plus sign and it is attached to this 6, I cannot cancel out anything but another x squared plus 6. Okay, does that make sense to everybody? Again, like I said, that's the hardest part of this lesson. As long as you can remember that whenever a variable has a plus or a minus sign right beside it, it is attached to that pair and it cannot be canceled out unless it is something identical. Okay, now let's look at this last problem. We already went ahead and put parentheses around x plus 4 because I know it's a unit. It's a pair. There's nothing that can cancel out with it unless I see another x plus 4. Which, is there another x plus 4? No, there is not. So, is there anything here for me to cancel out? Nope. This is my final answer. X plus 4 over x. There is nothing to be simplified in that problem. So, that would be your final answer. Okay? Let's go on to the next example. Now we're going to bring in what we learned last week and this week, and today's lesson combined. Okay? Now, first of all, first thing that should be on your mind is to put parentheses around any variable that has a plus or minus sign beside it. So what do you see here that I need to go ahead and put parentheses around? Someone look up there and tell me. 5 minus 10x, very good. This is a pair. I cannot cancel anything out. And what's the other one on the second problem? 2x minus 6, very good. Okay, now I've found my pairs. I know that there's nothing that can be canceled out with them unless it's identical. And this is my final answer. Well, but this is where last week's lessons come into play. Look at what I have inside of parentheses on that first problem. 5 minus 10x. Do you see a greatest common factor in that problem? Yes. 5 and 10, their greatest common factor is 5, right? So I can pull that outside of parentheses and then I can simplify this. So I leave 15x just like it is because there's nothing that I can do to it right now. But I'm going to take out that greatest common factor of 5 on the bottom of my fraction. So remember, now I divide. What's 5 divided by 5? 1. What's negative 10 divided by 5? Negative 2. And then I did not do anything to the variable, so I leave that x there. Now, is there something for me to cancel out? Yes, there is, because I've got that 15 and that 5. Now, what number can go into both 15 and 5? 5. Very good. So I cancel it out. 5 goes into 5 one time. 5 goes into 15 3 times. Is there anything left for me to cancel out here? Nope, there's nothing else. So I write my answer as 3x over 1 times 1 minus 2x. Now, this 1 right here on the outside of parentheses, you do not have to write that because it's a 1, and obviously it would mean distributive property. 1 times 1 is 1. 1 times negative 2x is negative 2x. So whether or not I have that 1 written is not going to change anything about my answer. Now, obviously, if it is a 2 or a 3 or any other number besides 1, then it matters. You have to write it. But if it's a 1, you do not have to write it. If you want to write it, go ahead. I'm not going to mark any points off, but you don't have to. So this is my final answer here. Okay, let's do this next one. Do you see any greatest common factors of 2x squared minus 6x? What is it, Cortez? 2 and an x. Very good, because both of these have an x. So I pull a 2x out, and I'm going to be left with, what is 2 divided by 2? 1. If I had 2 x's and I pulled 1 out, how many am I left with? 1. Very good. What's 2 divided by negative 6? Negative 3. If I had 1 x and I pulled 1 out, how many do I have left? None. So I don't have to rewrite that x, okay, because I don't have any left. Now I put it over 6x squared. What can I simplify now? 2x and 6x squared. Very good. What number goes into both 2 and 6? 2. 2 goes into 2 one time. 2 goes into 6 3 times. Okay? And then I can simplify the x's. I've got one x up top that can be canceled out. So that means I can cancel one of these x's on the bottom. So I'm still left with an x there because I started out with 2 x's on the bottom. Okay? So my final answer is going to be 1x minus 3. And again, I'm choosing not to write that 1 on the outside because that's the only thing I'm left with. Over 3x. Is there anything left for me to simplify here? No, there is not. So this is my final answer. Okay, I want you to do this problem on your own. All right, I want you to use what we've learned so far and do this problem on your own. I'm sorry, I did not mean to write equals there. All right, so first step that you should do here is you want to put parentheses around any variables that have a plus or a minus beside it. So that means I put parentheses around here and here, both of them. So I realize, okay, if I don't have something identical, I can't cancel out. So right now it's looking like this is going to be my final answer. But you've got to look for a greatest common factor inside of the parentheses. So I look at my numerator, 16 and 8. What is the biggest number, because that's what greatest common factor means, that can go into both 16 and 8? 8. Okay? I can take an 8 out. So that's when I divide. So I say 16 right here divided by this 8 that I've taken out, and I am left with what? 2. So I write my 2 right there. Now what is 8 divided by this 8 that I've taken out? 1. So I take a minus and then minus 1 there. And then did I do anything to that x squared? No. I realized that there was no variables I could take out, so that stays just like it is. Are there any greatest common factors that I could take out of 2 minus x squared? No. So I leave it just like it is. 2 minus 2 minus x squared. What do you see now that I can cancel out? What's identical here? Cortez? 2 minus 1x squared. Very good. Look, they're the exact same. So I can cancel those out. Finally, we have something in parentheses that will cancel out. But you say, but Miss Reber, on the first one, there's 2 minus 1x squared. And on the bottom, it's 2 minus x squared. What's that number that I don't see in front of that x that I know is there? A 1. So yes, it is identical. And then I'm left with, okay, listen to this carefully. Anytime you cancel something out and you're left with nothing, it's either going to be on the top or the bottom, what you write is a 1. It is not a 0, okay? So I'm left with 8, and since I have nothing on the bottom, I write 1. Well, what is 8 over 1? 8 is my final answer. Okay? So everybody hear that. Whenever you cancel stuff out and there's nothing left, let's say every single thing cancels out, then my answer would be a 1, not a 0. Okay? All right, let's go on to this last example. Now, this is probably the trickiest of all the examples, and this is actually example 3, not example 4. That's wrong up at the top. But it's called recognizing opposite factors. And what that means is when I have something that looks the same, but their signs are the opposite. And there's a very simple way that we can fix it so I can cancel it out. But before I do any of that, I've got to look at these problems because these are different than the ones that we've done in the last 2 examples. Up top here, first of all, somebody tell me, what should I automatically do first step before I do anything? Put parentheses. So I realize right here I need parentheses. But look at this denominator. I have x squared minus x minus 2. So does that mean I need to put parentheses around the whole thing? Just x squared minus x or x minus 2? I don't know what to do. Anytime you have a trinomial, that means 3 terms, x squared minus x minus 2, always check to see, can I factor this? Because 9 times out of 10, it's going to be, yes, I can factor it. And that's exactly what they want you to do. Okay? So let's look at this. Let's list the factors of 2, because I know I've got to list the factors of c. Obviously, the factors of 2 are 1 times 2. Now, since this is a negative, I ask myself, which one subtracts to give me negative 1? Remember, that's a 1 right there. Obviously, 1 and 2. That's my only option. So I'm going to rewrite this as 4 minus x squared. Keep that just like it is. Over, then I'm going to have 2 parentheses. I'm going to have x, 1, and 2. Now, I need to figure out what signs I'm going to have. I know since this is a negative, one of them needs to be plus and one of them needs to be minus. So I look again at the sign in front of b. That is a negative. So the negative I know has to go with my largest term. All right? Now you may say, okay, that still doesn't do anything for me. I've got 4 minus x squared. Now, anytime you have terms inside of parentheses, like our numerator here, ask yourself, can I take out a greatest common factor? Well, no, 4 and negative x squared, there is no greatest common factor. The next question you need to ask yourself is this the difference of 2 squares? Remember when we learned that last week, the difference of 2 squares? Okay, so let's look. What's the square root of 4? 2, okay. What's the square root of x squared? X. Is it the difference or is there a minus sign? Yes, there is. So I know automatically I have the difference of 2 squares. So I'm going to put parentheses up here. I'm going to leave what I have on the bottom. And I know that the square root of 4 is 2. So the 2's go in the front. The square root of x squared is x. So those go in the back. And what do my signs have to be on the difference of 2 squares? Plus and minus. Very good. Now, I look again and I still look and I say, there's still not really anything that's canceling out because I've got 2 minus x on the top And it looks like it could possibly cancel out with x minus 2, but it's not identical. And remember, it has to be identical, okay? There is one way that you can make them identical. Since I have 2 minus x, in order to make it identical, I can factor out a greatest common factor of -1. You can always factor out a greatest common factor of -1 when you see opposite factors or something that looks identical but they've got different signs. So let's try that. I'm going to take this problem right here, which is 2 minus x, and I'm going to factor out a -1. So I write the -1 on the outside of parentheses. What is 2 divided by -1? -2. What is -x divided by -1? Positive x. Okay? Now, that means I've done away with that term, and my new term is now -1 times -2 plus x. So let's look at this. Is this going to work out? I look at this problem right here. Is x positive or negative on the denominator? Positive. Is x positive or negative on the numerator? Positive. Okay, that's working out. Is x positive or negative on the denominator? Not x. Is 2 positive or negative in the denominator? Negative. Is 2 positive or negative in the numerator? Negative. So even though they're written backwards, they're still the exact same. So now I know I can cancel those out. Okay, now I know I can cancel those out. So I'm left with what you want to do. Anytime you factor out a greatest common factor and it's left there, you always want to write that at the very beginning. So I'm going to write -1 times 2 plus x, because that's what I'm left with on the top, over x plus 1. Now this is my final answer. Now that you know that is what we did, listen, now that you know, in order to cancel out opposite factors, I've got to pull out a -1, okay? I've got to take out a -1 of greatest common factors. Here's a shortcut that you can tell yourself. Anytime I see opposite factors, cancel them out and leave a -1. That's all you got to do. Cancel them out and leave a -1. Because what I could have done here is, so I could have seen, oh, these are opposite factors, so I'm going to cancel them out and leave a -1. Because that's all I did in my final answer there, okay? But I want you to know that where did that -1 magically come from? Did I just write it there? Where did it come from? I had to factor it out. I had to take my greatest common factor, which was -1, and change it. All right, so let's do this last problem. X squared minus 6x plus 9. Do you see anywhere that I need to go ahead and write parentheses? Yes, where? 9 minus x squared. Very good. All right, what do you think they want me to do with this numerator? Factor it, because there's 3 terms there. So I go ahead and I write the factors of 9. 1 times 9 and 3 times 3. Which ones are going to add, because 9 is a positive, to give me 6? 3 and 3. So I'm going to use 3 and 3. So I've got, now on my new numerator, I've got x and x, 3 and 3. And what do my signs have to be? Minus, minus. Very good, because I know anytime this is a plus, my signs are either going to be plus, plus, or minus, minus. So I look to this term right here. If it's a minus, they're minus, minus. So that's exactly what I did. Now, let's look at my denominator. 9 minus x squared. Ask yourself, is there a greatest common factor I can take out? No. 9 minus x squared, there's no greatest common factor. But is it the difference of 2 squares? Okay, let's find out. What's the square root of 9? 3. What's the square root of x squared? X. Is there a minus sign? Is it a difference? Yes. So I know I can do the difference of 2 squares. So I write the square root of 9 is 3. Square root of x squared is x. what do my signs have to be? Plus and minus. Now, do you see anything that looks like it's going to be able to cancel out, but it's opposite? It's not exactly alike. X minus 3, and what's the other one that still has a minus sign in the middle? 3 minus x. These two terms right here are my opposites. Okay? So what did I tell you you can do when you have opposites? Cancel them out, and what do you leave behind? A negative 1. Now remember, you can leave behind that negative 1 on the top or the bottom. It does not matter. You can leave behind the negative 1 on the top or the bottom. Okay? Where do I put that negative 1 when I write my final answer? In front. So I write negative 1 times x minus 3 over 3 plus x. Where did that negative 1 come from? Exactly. But where did I get it? Does it just appear when you cancel out the opposites? It's the greatest common factor. Very good. All right. That is lesson 11.4, which is simplifying rational expressions.